Welcome to the solutions to the Regents Physics Momentum problem set, problems number 1 through 5. Let's go ahead and get started. We've got our introductory set of questions here on momentum. Number 1, can a bullet have the same momentum as a truck? And explain your answer. Well, the answer is possibly. Recalling that momentum is a product of an object's mass and velocity, the symbol for momentum is lowercase p, so here we have momentum subscript b for bullet. Could it be equal to the momentum subscript t for truck? Well, the bullet has very small mass, but very large velocity. The truck has large mass, but goes at a much less velocity. So depending, of course, on the masses and velocities, we could possibly get the product of this mass and velocity to equal this product of mass and velocity. So it is possible that a bullet could have the same momentum as a truck. Number 2, why are cars made with bumpers that can be pushed in during a crash? Well, this is the car safety application of your impulse momentum theorem that we just discussed in a previous lesson. And of course, the idea here is that the car has a crumple zone that absorbs the impact forces. And if we take a look at the impulse momentum theorem, here we have the impulse denoted by capital J equals the change in momentum. Change in momentum must occur either due to a change in mass or a change in velocity. Well, which is the case here? Well, during the collision, the car will likely maintain most of its mass. It might lose a bit of mass, but for the most part maintains its mass. But the main change in momentum comes due to a change in velocity. And change in velocity is final minus initial. Let's suppose the car was going 60 miles per hour and then came to rest, which of course would be 0 miles per hour. Well, no matter if the car had a crumple zone or airbags or seatbelt or any of the other safety features, that car is still going to go from 60 to 0 miles per hour upon impact. So the change in velocity when we compare different scenarios is not going to change. What does change? What happens here is that we increase the amount of time over which the force of impact acts by having this crumple zone, and therefore reduces the force of the impact itself. So this is why cars are made with bumpers with crumple zones that can be pushed in during the crash, to reduce the force ultimately on the occupants of the vehicle. All right, next, number 3. You are sitting at a baseball game when a foul ball comes in your direction. You prepare to catch it barehanded. In order to catch it with the least amount of pain, should you move your hand toward the ball, hold it still, or move it in the same direction of the ball at impact? And explain. Well, again, here, this is very similar in concept to the car safety application, except it's your personal safety with your hand here. The ball's mass or your hand's mass is not going to change during collision. The change in velocity of the ball is the same regardless of any of these 3 scenarios discussed. It's going from whatever velocity it impacts your hand with to 0. But what does change if you move it in the same direction of the ball at impact? In other words, give with the ball as you're catching it, is you're increasing the amount of time with which the force acts on your hand during this change in momentum, therefore reducing the force on your hand. Check out this scenario. Here's a dedicated fan who's catching the ball with her glove while holding her baby in the hand. But it's okay, because her baby has this safety little helmet on in case she drops him. Let's move on to number 4. We have your brother's mass is 35.6 kilograms, M, and he has a 1.3 kilogram skateboard, M. What is the combined momentum? So they're asking us to solve for little p of your brother riding his skateboard at a speed of 9.50 meters per second, and that of course is v. I hope you're in a good habit by now in this course of underlining your variables as you go and identifying them with the correct letter. Helps you be successful. P equals mv, the equation for momentum. And we have a combined mass of the skateboard and your brother that you have to add the mass together and multiply it by their speed of 9.50 meters per second. Multiply and to 2 digits, you get 350 units. Mass is in kilograms, velocity is in meters per second, so units of momentum, kilogram meters per second. Lastly, number 5. We have a hockey player makes a slap shot exerting a force of 30 newtons, F, on the hockey puck for 0.160 seconds, so that's time. And what is the magnitude of the impulse? And the symbol for that is capital J, given to the puck. Right off your reference table, the formula for impulse, capital J, equals F times T. Substituting, we have 30 newtons times 0.160 seconds. And this gives us an answer of 4.8 units of force are newtons times time, which is seconds, so Newton seconds. Note that's a Newton second and not a Newton per second. That'll do it for the questions 1 through 5 as your introductory set of problems and questions for momentum. More to come in class as we do problems 6 and 7 together in class.